Good evening, everyone. Today the lightning talk will be about the sizeof operator. Let's start from the beginning. What's the definition of a sizeof operator? Basically, it returns the size in bytes of the object representation of type. But here comes the first question. How many bits has a byte? Any guess? What would you say? Not 8? Different than 8? Who says 8? Okay, basically it depends, like in a lot of stuff in C++. Depends on the architecture. It has to be at least 8 in C++. And you can check it in the char bit. Okay, now let's move to how it behaves, the size of. Size of a char, any guess? 1. Size of a boolean, any guess? Implementation define. Size of a short, implementation define. The same for an integer, the same for a long, the same for a pointer, the same for a float, a double, and a long double. Okay, let's try to go with a specific implementation. Size of bool, it's 1 here, short 2, integer 4, long 8, pointer in this case it's 8, it's 64-bit, float 4, double 8, and long double 16. But the question is, okay, do the standard guarantee something at least? Well, it guarantees that size of char is smaller or equal than a short, smaller or equal than an integer, smaller or equal than a long, and smaller or equal as a long. Do you see some particular case here? Yes, the standard guarantees, it allows that. You can have size of long that is 1. Okay, but how can we know it's 4, it's 8? Well, basically we have these two. The common data models depends on the 32 bits and the 64 bits, and basically the more common we have 4, 2 for the 32, 2 for the 64, and basically mainly it's like depends if you are on Windows or Unix, you have one data model or the other one. This would be a way to more or less know. Okay, now let's move to structs. What would be the size of an empty struct? Yes, it's 1. It's empty class, it's always 1. Okay, let's see the size of a struct, that is a boolean. Here it's also 1. Yeah, in this case I put at the top, that is with this implementation. In this case it's 1, 0 overhead. This is what we want. Let's do the same with an integer. We have 4, the same, 0 overhead. Okay, let's move here. Now we put a boolean and an integer in the struct. What would be the size of this? 8. Well, in this case it's 8. And the size of this one? It's 12. And the size of this one, that is exactly the same, we just change a little bit the order. In this one is 8. Maybe we should take care of how we put the elements in our structs. What happened basically? Yeah, here we have some padding have been added. The basics types, they have to be aligned in memory, and basically the compiler adds some padding. Also, it's implementation defined. It would be too easy that you can really guess the padding. But you have the line of, if you are interested, that you can know how they are aligned. Okay, how it behaves the size of in reference and arrays. What's the size of a reference? Well, it's the same size of the type of the reference. What the case in this built-in array? What happens if we do size of foo? Well, it behaves more or less as expected. Size of t multiplied by the number of elements in the array. What happens if we do it in an std array? It's the same. Std array, it's nothing else than just a built-in array encapsulated. It's not a problem yet. Okay, now let's move to std vectors. And why not? I would like to do the same. I want to do the size of foo. What's that? What will be the result? Abomination. In this implementation, it's 40. Okay, but you check Stack Overflow, you find some other ways to do it. Okay, let's do it this way. Let's grab the size of the first element and multiply by the number of elements. Will it work? What do you say? It's a little bit on the boundary. It's a little bit tricky, I have to admit. Well, it's giving 160. But why? Well, because it's a vector of booleans, and the type of foo, it's not a boolean here. Basically, it's a reference to boolean, blah, 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 because the vector of booleans, it's optimized. If it would be integers, this would work as expected. And then, okay, how we could do it? Maybe we could just do some kind of helper function that returns this way. And basically, that's all. Thanks.